Okay, then I'll start. Thank you for introducing me, Frederick. I'm a PhD student under Oliver Deussen. I'm the first kind of technical artist from the Constance team. Later, Daniel will talk about the side from the UK, from London. And I'm kind of a bit of an oddball, I would say, in the team, since I'm sort of trying to go for both developing kind of my own artistic personality in this project. But I am an upstart in computer science, so when I started my studies in Constance, I never expected that I'd work with the arts in general later on. I was kind of a bit more of someone who enjoyed working with algorithms, enjoyed working with maths, going for optimization processes, which is at least in a direction that I think is very interesting in arts, which is like dynamic kind of structures, dynamic paintings, a bit messiness in my works. So it's kind of completely the opposite direction that I took in my studies before. So in this talk, I want to go a little bit with you through what we've done technically, what I've been working on in my PhD, to get to this kind of idea of I have a photo, I have an image, and this is what I want to paint. It's a very simple concept, I think, to really just, you have something in your photo gallery that you really like, and you want to have something of an impressionist rendering representation of that on canvas, hanging in your living room, or just showing it to whoever you like. Okay, so this is the machine that we have in our atelier, in our robotics lab in Constance. I think some of you might be familiar with how Oliver and PhDs that came before me coined the whole system, the David robot that we have. This is one of the now 3 models that we use. This is our large ABB robot. These are very well known, not really in the artist space, but more in the industry, since these could very well be at a factory from BMW, either welding some metal parts together, moving around boxes of screws, or screwing bolts onto different car frames. But in this project, we really wanted to use this precision optimized machine for just producing nice arts, swinging a brush as a soft tool, which is completely opposite of what you want to have in industry. You want to have repeatable conditions, you want to work with metal on metal if possible, things that don't bend, don't break, don't change over time. But a brush is soft, and depending on how you move the brush, it moves in completely different directions. It can start having a bit of a swing. It can start to really burst apart a little bit, leaving different types of brush marks, depending really on how you approach it on the canvas, and also depending on other things with the materiality that come into play that also change how the brush might behave on the canvas. Like if it's either a canvas board that you're using, just paper you're painting on, or you might paint like I like to do now on soft stretched canvases that also leave some springiness, some feedback, depending on how strongly you apply the brush to it. So before I started to take this project over, what we were trying to achieve with the system was to sort of also embrace the precision of the robot a little bit, and just working on a simple feedback loop together with an input as a reference image, and then using a semi-transparent acrylic color and the same kind of brush pattern that Thomas Lindemeyer at the time really optimized to look like a nice brush ductus, to kind of apply it to the canvas with one kind of approach for it, and repeating that over the whole canvas until for every pixel of our input reference image and every pixel on our feedback canvas that we capture continuously with the camera, that they kind of match. But if we are applying many strokes at a time that have the same look, and we're really trying to optimize it on a very small scale for every pixel and reference and canvas, then of course we will never converge to the perfect kind of reference image that we have in mind, leaving us with this very impressionistic and strokey kind of abstraction that we can see here. And there's no real underlying structural or compositional thinking that our system had in mind when just starting it, or the whole system had no idea how exactly it will look like after the process is finished. We only started with a photo and then applied strokes at specific locations on the canvas that just look the same until after many, many iterations, after many, many layerings of the same types of brushes, just with different colors on the canvas, we sort of converged to what looked like the original image. And while these look amazing, and I love every one of them, we were trying to look at new directions, how we can more direct the result and steer what we want to have also from a compositional kind of direction. So we wanted to have a conceptualized painting in a sense that we're looking for different regions of whatever we are trying to paint, different patches, different parts like leaf structures, maybe tree barks or grass that we want to represent, like more of a conceptualization of what we see based on what it is, or maybe based on the texture it has, or maybe just the color it has, and then apply that instead. So it's kind of a shift that we want to do, going from this individual brush perspective to a more conceptualized strategy of painting regions instead. And to achieve that, we changed a little bit how our pipeline works in general. So instead of continuously just applying brushes onto the canvas, we now first conceptualize our painting in the first stage based on an input image again. And this is what we have on the left side, which is the image abstraction, which I've spent a lot of time in the beginning of my PhD to work on this stage. So for the first 1.5 years, I didn't touch the robot at all. It was just standing there, and I was working on conceptualizing how can I get from just a photo to regions where I think that they make sense to paint, or even to get a system that allows me to tessellate this image in a useful kind of manner. And there are many systems of which some of them I will come back to in a bit that might be interesting, at least from the computer science side. There are a lot of these systems, but all of them, let me take that before we come to it later, are focusing on one key aspect to optimize a metric, which is nice and all if you're looking for cancer diagnostics on the medical domain and want to segment your images. This is like the fancy word for tessellating your image into regions. Or if you're looking at tessellating other kind of inputs where it doesn't really matter what you see, just the structures are interesting. For that, there are many different systems, and they work wonderful also for the medical domain. But what we want to split into these regions are usually objects that have different meanings for us, objects that have semantic substructures, like you see in this picture of a pagoda. This one was already abstracted, so this is not the original image here, but this is already a split kind of image into different regions that we stacked on in a hierarchical tree, kind of, where we have big regions on the bottom and large and smaller, more detailed regions on the top that we layer later in the painting. But for here, we really want to find structures that, for us, also make semantically sense. Like different wooden beams that are connected on this pagoda that need to belong together to make sense as a frame, or the wooden tile, or the roof tiles of the pagoda that should be kind of one structure that can be represented with some texture in the painting. So we're not only looking visually to what might make sense, but also to what makes structurally sense to paint. And this is what has taken me, I think, a lot of time to also comprehend what we need when everyone else was working to optimize some kind of metric that might make sense in their niche domain. But when I apply this kind of conceptualization to any kind of image that I want to start with, it falls apart. You cannot just apply one metric. So this is my approach to how to get to this stage from just a simple image to an abstract representation that we can use as a concept to start with. And this is just the first part. Then once we have a concept down, what we really do is to, of course, we want to apply that to a robot, right? So the next thing, once we have this kind of region structuring of our input, we really want to find the strokes. So we're getting back to the individual stroke within all of these regions, and then see how it's going live on the canvas. Since in theory, we could just, fill our region with whatever, throw that to the robot, and do kind of paint by numbers type of system, which would be, of course, possible, and many people do that, especially when working with something like a plotter, where you want to achieve perfect precision, very fine lines. You might maybe not even use a brush, but something like a marker or a ballpoint pen to really get straight lines and or maybe nice spirals that can fill any kind of given shape in no time with nice repeatability over time. But I think what at least makes paintings nice for me is also to have this kind of dynamicness in it, where I cannot really pre-produce anything or predict what comes out in the end. So what I, in my system, kind of propose here is to have this concept of these regions that we want to paint, and then fill them dynamically. So at any given time, we just compute a couple of strokes, send them over to the robot, have the robot execute them, and then we use our feedback camera, which is like here on the bottom. In the lab, it's mounted on the ceiling, so we can track the canvas from above, and then see, okay, we had our simulation, what we thought our strokes might look like, that we have computed, sent to the robot, and then we can really inform our system of how it really came out in the end. So the system can then decide, okay, I have my simulation, I compare it directly to what came out in reality, and to then make adjustments dynamically to the parameters, to the length of the strokes, to, okay, where do I place strokes next? Because in my plan, I want to finish my region, sort of. That is maybe a part of the sky, a part of the pagoda, a wooden beam, or a bit of grass. And to achieve this kind of coverage of this region, it then plans new strokes accordingly to what the physical canvas really looks like. And if you apply this in a feedback loop to go back and forth from the reference to simulation to robot and real painting, I think we can get to something that is much more dynamic, or like an internal conversation between the robot and the control program. And this is even not involving me or any other person for now. So this is just the robot interacting with the physical canvas and then doing dynamic decisions. Yes. So what do I mean with these kinds of regions? As a bit of added context, this is a little bit of the direction I want to go, where we have many different, of course, objects that we want to represent, different concepts that we see in what we want to paint, in what we want to see or even feel. And I'm trying to break this down into, because I have to simplify in my work. For me, to produce this kinds of conceptualization, I have to find some simplification for paintings, and to find this one kind of style that the robot currently has. I'm trying to find these regions that I then paint in with some structure, some texture, some stroke finding algorithm that I kind of came up with, to then generate a similar feel to what real artists are trying to do with oil paintings. Yes. So, how do we get to this? How do we get to this kind of stage where we have this concept that we can then use to fill individual regions? At least from the computer science, what we usually start with is to over-segment an image. This is kind of what anyone from the medical domain would do to the autonomous robotics people, or even the guys that produce segmentation algorithms for satellite imagery. Everyone starts usually with some over-segmentation, and then what we do is we define some sort of criteria based on which we want to merge regions together, and this is kind of our image segmentation that we then kind of could use as some initial plan, kind of, which is in this stage completely uninformed of anything that is in the image. It's just based on some simple statistical metrics. Maybe it's color, maybe it's some texture, high frequency components that you are looking for. But it's of course missing the point. I think many of these strategies are only looking to optimize for something that is within the image, like some numbers, but not really looking at what we actually want to represent. And at least what I want to paint is I want to have the flexibility of just taking a photo of a person, a car, a squirrel, or maybe even the burger I had for lunch, and maybe I want to paint that. So the system also needs to be able to kind of have some sort of comprehension of what we're looking for, and doing this paint plan also based on what it is, instead of just painting by numbers. So what we kind of did, this is like another failure case for some of the very recent papers that came out, also with some image vectorization schemes where people are trying to fill splines or use machine learning for finding regions in images and representing the picture with that. But all of them are not really what we are looking for, because I think it's not as clear from the back, but this is kind of machine learning based image optimization for finding different regions, like I'm trying to do in images, just telling the machine to do it, optimizing for shapes and colors. And at first glance, it looks okay-ish, but on second glance, the whole geometry makes no sense. There are structures that are sticking out, poking randomly, random holes within the whole image. And also, there is so much overlap of these regions that if I were to try to paint it on real canvas with colors that subtract from each other, that really I cannot easily layer without considering perceptual view on how the pigments work, and just the physics of layering color on canvas. This is something I just cannot use. So this is kind of our full pipeline that takes these things into consideration, where you first use machine learning to get, like Patrick already said something about attention, and this is also what I'm making use of in my system, where of course we're using some machine learning based method to get an idea of what an AI might find interesting in a given image, what are structures that are important to highlight, and what are key elements of the scene that we see. And I will show this in the next image. So this is something that I took from my model internals, which is kind of a representation of what the system perceives to be important on the left. This is kind of the structures for the St. Paul image of what we have in this scene. And on the right are different kinds of modalities to highlight what are some sub-elements within these objects. So the first step is to kind of identify what are even key objects in the scene. This can be a building, the sky, a road, a person, or different people, or vegetation. And then to get a sense of what else makes these elements different from each other, what are key structures within what we see. And this can be a corner, something that is like here, which is a depth estimation that works automatically to really see, okay, what are structures that are further away, what is closer, because all of these things are important to us, are important to highlight and to show and represent in a painting, I think, because otherwise of course you can go into very abstract stuff, but if my goal is to paint my kind of photo gallery to hang it on the wall, I also like to have the geometry to be kind of close to reality and to not be confused with a person mixing into the sky at some part and blending into the very foreground in another. So these are all semantically relevant concepts that I try to include in this process of doing this conceptualization. And the next thing is to, while we have these semantics, is how do we use these semantics? And this is kind of the second part, the second stage of the big framework we developed, is to use this machine learning-based kind of activation map or attention, as other people call it, to then group these initial over segments to be semantically correct. So this is how we get from just an image to a conceptualization that makes sense both geometrically as well as from a painting perspective, because these don't overlap unnecessarily. And what we can, of course, do with such a system is to construct hierarchies, but based on what we want. So we can define different layering schemes to get us to different hierarchies that we can then use with different colors, of course, that we know as artists based on our perceptions. We can choose and change the colors so that layering different regions also works. But this is all good and all. How did it start? With this. While, okay, this is the whole pipeline and framework was something bigger and was kind of developed continuously. One of my very first paintings that I tried with this region-based structure was this. I think I had a problem with defining the pressure. Didn't work. I guess I found the bug in the end. Well, the region tessellation was also a bit abstract, and if I didn't show you before that this was St. Paul's, I think at least my friends in Germany, they wouldn't have noticed that what the motive at play here was. But this was my kind of first attempt at working things out, and with trying new things, introducing machine learning, working also on different kind of region groupings, iteratively developed the system to look much more natural, much more real, much more like an actual painting. And while this is, I think, a nice result, it's still a bit amateurish, I think. And I'll show you some newer results in a minute, but I think a key contributing factor along this kind of journey were also the artists that we were working with. And I enjoyed actually every interaction with every artist, whenever we met with Patrick, with Licia in London, with Frederick, working with Daniel, working with Anna, who's also here in the back, working with Greta. We tried so many different things, so many different kinds of concepts that we were working with and playing around with. I had my own ideas, Anna had her ideas, and here are some of the results that we came up with as some trials, and this was in the very early stages of the EACVA project. And I think we had a lot of fun also together to just meet up, and we are in kind of the same space and one community, and I think it's nice to also interact more with others in the space, because everyone has their unique ideas, and trying to realize them together on one system or maybe both systems, and having like a nice just comparison of what we do, nice exchange of ideas, definitely contributes to improving everyone's work. And here's some of the first things I did with Greta. It looked terrible, to be honest. I didn't fix the pressure bug yet. It was a nightmare for me. One of my first interactions, and the result was not only disappointing for Greta, but at most for me. And here is the robot working on the second attempt, where I believed I had fixed the pressure bug, but all I did was instead to make it a pointillist artist, because now I had another bug where the stroke length was kind of calculated wrong, and most of the stroke placement was done with a dot. And I stood next to him and thought, okay, this is amazing, because I cannot stop it now, otherwise we would have to restart. And at the end of the day, we only had a limited time to interact together. So we just rolled with it and let it continue until it was done. And then later on, after many fixes, many more trial runs, introducing much more semantics, much more structure, working on the algorithm for placing strokes that I'm still working on to this day, we finally got to some more interesting results, I think. And our motive with Greta here was especially working with orchids and trying to combine this kind of flowiness of orchids and flowers with this robotic systems that are usually known to be these rigid structures. And here are some other works I did in between, me finding also my own direction. This was one commissioned work. So this is kind of how the system runs. Also makes a very unique sound in that sense. I don't think you could stand a long time together with the robot, because I usually use the noise-canceling headphones to protect my ears, but it's really screaming at you. The joints, the controller, they're screaming, literally. Yeah, and here are some more recent works we did. This one was a diptych that we did with Greta, where you can see the production video we have in the church. Greta has her own video. Unfortunately, she couldn't come. And very unfortunately, the original paintings are now stuck at Stansted Customs. That's it. But I think they came out amazing, and the key idea here was to switch agency around. So one part was done by the robot, and another part was done by Greta as a traditional painter. So we have this kind of, I think, also this asymmetry in just quality and representation. But it's not all that Greta was much better and much more precise. I really also liked how the impressionistic petals came out here a lot. So it's just also a matter of style that we're going for, where we want to find a unique way of visualizing what these types of computer systems can bring to canvas. And here are some other works that we did. This is how my office looks like on the left, with some more recent paintings that got much more sophisticated. And I'm now confident that at least for this one style, the E. David robot has found its kind of niche. And yes, this is something that I'm now further looking into, like how can we get better strokes infills for our regions? How can we get that to canvas nicer? What are other considerations that we can do? Like, I mean, here in this image, it looks a little bit boring how the robot is approaching the canvas. Of course, it's trying also to make my job easier, to make it more repeatable, and to analyze the system if it's just approaching it perpendicularly and then doing its brush. But of course, there are some ideas and approaches of really making the robot head move much more fluently, much more dynamically, like a human artist, tilting the brush more. And so this is some more recent work direction to kind of make it much more human-like in also its performance style. And also color is, of course, a big consideration. usually when you are trying to get a color palette automatically for a given input image, what you get is something more in the center image each, which is representing and optimizing for texture. So you don't want to lose information from your image. You want to preserve as much as possible. But of course, the girl sitting in the grass is not green, right? She has a healthy-looking skin tone, or the stem of this flower is also not this kind of reddish brown that the automatic system chose. So I'm also right now working in semantically in informing and also steering color quantization processes to get nicer palettes that maybe the result loses a lot of color. And maybe the result loses a lot of information, a lot of texture. Sure, but this is not really what we want to optimize for, right? We want to really have colors that represent what we think is important, structures where we think this is good to have that as in a correct tone and not changing too much in there. When other parts, like if the grass has one less green tone, whatever, it's not relevant, it's not interesting for us. So this is also where I think some of the technology is a little bit stuck on, and we might need some artistic perspective to get us to new directions here. Yeah, these are some more works we did digitally. The paintings up close that we did recently. And just as a final bit, for the painting that we did for the pagoda, this is a bit of a time lapse of how it's working. And I have another short video after that. With that, while it's running, I want to conclude my talk, and I'd be open for some questions.
I'm interested in your palette of colors. Do you just always have a fixed number of colors, like 8 or something? And you've never tried getting the robot to mix colors to get different shades?
Yes, a very nice question. This is what we've been chatting about with some people, actually, to really mix the colors dynamically on the fly.
Yeah. Because that's what the real painter does.
Exactly, exactly. Which makes it much more difficult to analyze what's going on and to track what's going on canvas, because I'm just using a camera and a white canvas, and if there's some color changes, it needs kind of a detection mechanism to see when something has been painted or what's the threshold of if it's been painted.
That feedback loop with your camera
exactly.
is going to be key.
So the color calibration is quite a necessary step right now, but it would be much more amazing, of course, to mix the colors on the fly, or even try to, instead of just pre-mixing everything, to have exactly what you want, to give a lot more slack and leeway in how the robot can dip into different colors at a time. This is definitely a direction we want to go in with more research, more trial runs, more exhibitions, actually.
Hi, have you noticed any issues with bias in the machine learning algorithms you're using? Because in image understanding, a lot of the algorithms are trained on a lot of automotive data, so they're really good at cars and traffic lights.
Yes, because the people that usually train these very big systems, they of course train it on a data set which makes sense for them. And there's like 2 very big ones that I can use, which have enough coverage for useful objects, also for just a general domain of imagery, which is one is MS Coco, which is like household objects like toothbrushes or coffee mugs, or tables, which is kind of nice for indoor kind of things, but doesn't contain as much interesting outdoor scenery. For outdoor, there's essentially just cityscapes, but this is of course focused for automated driving. The industry always needs to make money, so all of their data sets are kind of trimmed to work with one interesting use case for the industry, automated driving or indoor object detection. So I'm trying to find like a middle ground where I'm enhancing existing trained objects with my own models for and like enhancing the attention mechanism. Also, what I showed you wasn't just the pure internals of one pre-trained model, but I kind of enhanced it to give me much more information, much more just locations where the systems thought, okay, there might be something, which of course it's an obvious edge, it's two different buildings, but the whole system can only differentiate one building at a time. It just has this one class. It cannot say this is one building, this is building two, but it still notices that there's something, and I'm trying to leverage this something.
Thank you.
Just sort of, sorry to take it back the microphone, just to follow up on that. Have you tried using the segment anywhere models from
Yes.
Meta?
I'm using it.
Okay. I would recommend.
Hi, thanks. That was a really great talk. Two things, actually. One, have you come across a video game called 1111 Memories Retold in your research?
I know it, but I haven't delved too deep into it.
It's a game I worked on like 7-8 years ago. The graphics programmer did a GDC talk about, because that was like a painterly impressionist rendering system, and dealt with a lot of the problems that you're dealing with, but obviously trying to come at it in a very different way, because then the goal was to run on a PS4 at 30 frames a second, not to make a painting out of it. But there's a good GDC talk you should have a look at about trying to deal with placement of particles and sizes and all those different things. But the question I had was, you talked a bit about how you didn't want the strokes needed to correspond more to what was in the image and not break over boundaries and things like that, and be a more kind of accurate, painterly representation of what's in the image. But have you talked about going the other way a bit more and it trying to deliberately be more impressionist or abstract and like pick up more, let's bring out how the light's feeling and let's put more onus on that, or let's make this thing is more important in the painting of the person, so let's change the proportions and make it larger, or anything like that?
Yes, that's definitely also an interesting direction I want to go in. The first step is to just get something, again, accurate, which is, I think, always an important like a saddle point to get a system to accurately be able to tell what happened and what's going on. And I would love to do much more impressionistic and kind of more dynamic things. But this all takes a lot of time, because I want this randomness to be purposeful, kind of. To be not purely controlled, but at least I can tell in what kind of movement it can work in. And so I'm trying to get to a stage where it gets more controlled, yet less controlled, but with a purpose behind it. So right now it's first all about getting a bit more precision back in, because there's still a lot of things to work on, like smaller details to render, to realizing them properly, and then to reintroduce more dynamicness step by step.
Great,
Yeah.
thank you. Really interesting.
I have a couple of quick questions. One was related to models that you touched upon, and of course there's inaccuracies where, for example, with monocular depth, it's not quite metric, not quite precise. Same with semantic segmentation, might get the classes wrong, and so on. I was wondering if you also tried playing with Gaussian splatting, like monocular Gaussian splatting, in a way to explore this idea of like overlapping shapes and transparencies, but kind of the reverse process where it's subtracted on the canvas. So that's one question. And the second one is about the process. The robot draws, but have you tried kind of painting yourself and acting as the debugger as you do it manually to kind of meditatively figure out what is it that you want to get out of it in terms of the stroke, the tilt, and so on? And the last one is, if you thought about swapping the pixel input image with, let's say, for example, an already pre-annotated, if you will, like a structured vector file.
Okay, so for the first question about Gaussian splatting, it's amazing. I just haven't figured out a nice way of really working with these semi-transparent objects that I can layer on top without going back to the initial idea of how we approach painting. So I would have to find a way of combining these semantic regions back with Gaussian splatting again. But would definitely be an interesting thing to work on. Because Gaussian splatting produces amazing results and nice volumetric renderings. It would definitely be cool to make use of these ellipses because it's splatting them onto the scene also quite dynamically. Yeah. And the second question was?
The second question was about if you try to manually sort of debug, to make a painting yourself by hand as opposed to the robot, and try to think about the process of like what happens to the brush, to the motion, to then translate that to the robot.
Ah, so a bit of a transfer learning. We are actually trying to apply for a grant with transfer learning at the moment, which would go exactly in this direction. So where we could kind of also try to extrapolate what is important for holding a brush. It's like working with different tools and then trying to extract robot patterns from that. Yeah, you're on the right track, I think.
Sorry, and the last one was if you try to swap the pixel image with a vector file that, let's say, have the layers named or labeled in some way, that makes it easier for the machine to understand the structure.
Yes, exactly. If your starting point is already a vectorization, you can just plug it in directly. Yes, and this would make it much easier also, because then it's less of a scheduling problem where we have to kind of first find the optimal schedule that makes sense to paint, but we could inform the system beforehand what are regions to look out for, when to paint what. Would definitely make it easier, yeah.
Thank you again.